So good morning, good afternoon, and I hope I'm not saying good evening to somebody here. So welcome everyone. We have our people continue to join us. Let's wait a little bit to enable more people join us continuously. Okay, have still some minutes more.
Hello, everyone. Good morning, good afternoon. This is Peter Wang from Schneider Electric. And we have Dory here from IBB, Luka from Hisense, and Mr. Wu from Tridonic. It's great to meet you here today. And we are sure to give you our best presentation to let you know more about direct current in buildings and our solutions in China. Hope we can have more interaction in later. Thank you.
Yeah, you wait a bit. So we have people join us now. So
Okay.
let's a little bit. So let's start now. Okay, so welcome everybody to the webinar today. I'm not sure if you're already very familiar with direct current or just began to explore it. So no matter what, we are very happy to have you here together with us. I'm Dory, R&D Manager at ABB in Smart Power Division in China, and I'm very happy to be the host of this webinar to our session about unlocking the direct current. So this series, this time, this is the focus, both on urgent, inspiring, and direct current for net zero building. So this, we have bring some insight from China. So for us, the context is quite clear. So by 2050, we must have the net zero emission. So building accounts very big portion of the global energy consumption, and also for the CO2 emission. This means our building themselves must be transformed. So it's not just about the energy sources, but also how the power are managed, how the building are powered. Okay, so let me introduce our outstanding speakers today. So we have Luka-Dongzhe Li, Director of EU Home Appliance Research Center at Hisense. And we have Xuankai Wu, National Product Application Manager at Tridonic. And also we have Peter Chi, Alliance and the Market Influence Leader at Schneider Electric. And also we have Prashant Kurup, General Secretary of Current OS, and Raphael, the in charge of Current OS marketing activity together with us. So just some few notes before we start. You can ask questions in the chat at any time, and we have dedicated time after the session. And your camera and microphone, please keep it off. And if you would like to join us later, and we can invite you to have more sharing with us. This session is recorded. All the people registered will receive the link for the recording, and you can follow up Current OS on LinkedIn and YouTube. Okay, maybe before we start, I can give you some brief explanation how Current OS was created. So you see, we are living through this big scale electrification change. So it reflects in the type of the power we are having. So we are shifting into two fundamental ways. First, we are transition to this renewable energy at generating direct current. We have more power source generate direct current by solar panels, fuels, this hydrogen, and also batteries. And also we have more and more devices use direct current. So you can see our more cars and very increasing of the direct current, this data center and LED lights. All these kind of things are run on direct current. But our infrastructure is still AC based. So this creating insufficient through constant power conversion and strains our electrical grid. And there's still no global distribution framework allowing DC sources and nodes to interoperate. So this is the gap what current OS is addressing. So current OS, Peter, you can move. Yeah, current OS is an open, global, and independent platform. So we have more than 135 partners around the world. So current OS is harmonizing DC standards and holds licensed status with different organizations as UL and also IEC. So this webinar is expressing this kind of needs. And so you can see Asia is quite.
Hello.
Can you hear?
Yeah.
क्या बोल रहे हैं?
We can hear
आया
you.
नहीं,
Let
अभी
me
तो टेस्ट होना
deactivate.
उसको.
Yeah, we need to mute.
Sorry, I'll deactivate sounds of participants.
Yeah, ABB, you can see on top, ABB and Schneider, and other companies is quite the partners, valuable partners for the current OS. And also we have high committed from Asia about this DC trend. We can see a lot of partners from China, like Green, like Hisense, like EV Power, and also Weinan Technology, and also different universities from Xi'an, from Shanghai. And Nanjing is also the partner of current OS. In Japan, we have Fuji Electric, Dakin, and also in Australia, we have D3 Energy, and also other universities and organizations from worldwide. Current OS has this core principle by learning from the real deployment. You can see we have different DC projects worldwide across buildings, mobilities, and infrastructure and energy storage systems. So these examples include commercial buildings, charging sites, campus, hospitals, roads, and public lightings. So this demonstrated that DC is already operating in public, in real-world environment. Over to you, Luke. You can have more deep dive about. Yeah, please.
Hello, everyone. My name is Luka Li from Hisense, and I work for Hisense EU R&D Center. Nice to meet you, all the fellows and all the friends. Okay, so I'll start my presentation. So the presentation is aiming at industrial and commercial scenarios, smart, flexible adjustment of DC air conditioner. Okay, so the first part is the introduction to Hisense commercial air conditioner. Okay, and Hisense Hitachi was established in the year of 2003. At the same year, the first generation VRF products launched to the market, and after 20 years development, our business covers A2A VRF, water source VRF, chillers, heat pumps, etc. In 2024, the newest generation VRF S5 series launched to the market, which had the biggest capacity of single unit among competitors. And currently, we are the world's largest VRF production base and ranks the first Chinese market share for VRF systems. And the production area, it covers about 250,000 square meters, and we have 38 production lines and for annual production capacity is about 11.2 million pieces. Okay, and we're practicing a low carbon strategy for our factory full of photovoltaic roof, and the total capacity is about 4.6 megawatt, and annual power generation reached to 6.9 mega kilowatt per hour. Okay, next slide. And Hisense won the world's first VRF lighthouse factory, and the first sustainable lighthouse factory among HVAC industry. And we are the only one that had twin lighthouse factory. Okay, and for the lighthouse factory, we have several benefits. First one is the smart manufacturing. We have digital engines to drive the zero carbon revolution. The factory utilizes over 40 advanced industry application scenarios, over 90% using the AI, and 21 industry first technologies. And the second one is the green and sustainable. Focus on the carbon reduction through energy control and AI empowerment, which has shortened the testing cycles by 20.3% and reduced total carbon emission from new product testing by 31.7%. And the third one is the ecosystem and innovation. Reshape the industrial contract by providing green technologies across the supply chain, and pioneer dark workshop production, achieving a 63% increase in labor efficiency and 57% reduction in welding defects. And Hisense makes the most digitalization and AI to set new standards in high efficiency, low carbon manufacturing. Okay, so for the new production, we have the top floor unit, which in Chinese market is M3 series, and for the top floor VRF, we have the also the DC version like this, the high multi M3 DC series, and for the overseas market we have we call it S5 series. Okay, and we also have some water source VRF and also side flow VRF products, and we have some AC products. That's the unitary systems. That's the 1-on-1 or 1-on-2 combination. And we also have the VRF indoor units, all kinds of VRF indoor units. For DC version, we have the ducted type, the four-way cassette type, and we have another AHU kit, AHU indoor unit solution. For this page is the introduction for S5 DC version, and we have the top floor unit, and the unit is the capacity is from 16 to 36 horsepower, and the power supply of the auto unit is we have two kinds of power supply, and first one is the DC 600 to 800 volts. That's can combined with DC microgrid, and the second one is 380 volts three phase. That's only for emergency operation. And the top floor unit can be modular combination up to 108 horsepower. Okay, and the indoor unit we have 1.6 horsepower for the ducted type, and 0.8 to 3 horsepower for the ducted type, slim ducted type, and 1 to 6 horsepower for the ducted type. That these three units are most used in all over the world. Okay, and it can also compatible with two kinds of power supply. First one DC 300 to 400 volts with DC microgrid, and the second one is AC 220 volts, only operation in emergency. Okay, and the AHU we have two kinds of power supply. Also, we can have both DC 300 to 400 volts or DC 600 to 800 volts. It depends on the project. So the second part is the introduction to DC air conditioner technology. So this page is about the system topology. As you can see, it's the whole system of the microgrid with our air conditioner. So of course, the key component, the key equipment is the coupling box and the photovoltaic cloud and the energy storage battery and the grid, our unit. All the equipments are connected to the coupling box, and our unit can get the power supply, DC power supply, 700 volts from this coupling box, and our indoor unit can also get the power supply with DC 350 volts from this coupling box. And in case of emergency running, so our unit can also get the power supply, AC power supply, directly from the grid. Okay. So for this page, we call it working mode. Actually, for this kind of operation is the combination with the coupling box and our unit. So we have 6 operating modes to handle different environmental changes for higher efficiency. The first one is the grid for our unit. The second one is pure photovoltaic power to the grid. Okay, and the third one is the photovoltaic and the grid both generate the power for the air conditioner. And the fourth one is the photovoltaic power for air conditioner and the grid. And the fifth one is the photovoltaic power for ES and air conditioner. And the sixth one is ES power for air conditioner. Okay.
So ES means energy storage system.
Energy
right?
storage, yes, energy storage. Okay. So as you know, our unit has the most power consumption in the whole building, probably just because the air conditioner power consumption is a lot, of course. And the DC microgrids have low impedance and densely equipped with high frequency switching converters, resulting in localized high density EMI. Therefore, compliant EMC design is essential. Okay, our unit can pass both DC power supply and AC power supply EMI test, and especially for DC power supply, the unit is compliant both IT and TN grounding modes. Okay, as you can see the figure. So for this page, I need to introduce the intelligent flexible control of our unit. Okay, so we have the smart load function with voltage dependent power following for DC microgrids and achieving fast and flexible response of air conditioner load to boost bus voltage, thus the PV fluctuations for real time, the PV consumptions. Okay, and we have the function that control for faster response. That's the Droop control. And for this kind of control, we can meet the demand of the power, the DC power supply, the voltage of DC power supply, and reduce the unit power consumption at once. Okay, and with this process, we have the linear control scheme. And the red line shows the voltage. You can see the figure. The red line shows the voltage change, and the yellow line shows the power change of the unit. And the unit operates aligned with the voltage change, and the changing process is almost linear. It takes only 26 seconds for the changing time. Intelligent for this page is intelligent flexible function. That's the built-in power limited operation, and air conditioner consumes more than 40% of the building electricity. Real-time power regulation helps suppress building power peaks. Okay, and you can see the two figures also. If without the intelligent flexible function, the unit will run to the maximum power consumption, maximum capacity. And you can see there will be a peak, and after the peak, the unit probably with the vibration of the voltage, and it will also works with vibration. And if using the intelligent flexible function, you can see the power consumption is much more stable for this part. Okay, so for our power control range is about 20 to 100%. Of course, it's like a demand control, and it can be controlled by the third party, by the coupling box, or other controllers with RS485 connection. Okay, and the adjustment accuracy is about 1%. Okay, for the final part is about the DC project cases. Next slide. And we have several cases using in China right now, and not too many years, for about 1 or 2 years, but everything operates normally. Okay, the first case is for the commercial building in Beijing, and it's the DC air conditioner project in Beijing Fangshan Manufacturing Industrial Park, and the project scale is about 10,000 square meters, and we use M3 DC series 774 horsepower, and this one is the largest DC multi-split project in China until now. Okay, second case is the Taikai Group basketball court project, and we use this DC air conditioner in a stadium rooftop, and this stadium also have the BIPV. Yeah, and this one, the location is in Tai'an, and the project scale is around 1,500 square meters, and applicable models also M3 DC series with 136 horsepower. Okay, and the next one is the project in Jinan, the CSCEC R&D Center Shanghe Showroom DC air conditioner project. For this project scale is about 900 square meters, and the applicable and the model we use the M3 series also 70 horsepower. The next one is the Zhonghai Dajin Lane DC air conditioner project. So this one is also a commercial building, equipment rooms, and the project location is in Beijing. Project scale is 200 square meters, and we use M3 DC series for about 16 horsepower. Next one is the Qingdao Lufan Zero Carbon Industrial Park Technology Center DC air conditioning project. This one is in Qingdao, and it covers about 3,000 square meters, and applicable model is about M3 is about 156 horsepower. Okay, and in continue, the final one is the one we are trying to set up in Vichy, France. Okay, and it's also for commercial offices, and we also cooperate with Schneider, and project location is Vichy, France, and project scale is about 618 square meters, and we use the M3 overseas version. That means the High Flexi S5 DC model, and 20 horsepower. Okay, that's it. Thank you.
Thank you, Luka.
Thank you, Luka, very much. So I think this is a very brilliant technical deep dive, and also thank you for all the air conditioner, make our life more comfortable in this hotter and hotter season. And thank you, Hisense, that relieve my duty in consuming more energy, as I always keep the air conditioner on. You have more power efficiency solutions. Thank you a lot. Okay.
Thanks.
Yeah, thanks a lot. So in the buildings, so this is a critical piece is that the part is the energy, is the distribution and control. So at this point, we will have another speaker, Shankai, sorry, from Tridonic to walk us through their perspective on DC system in lighting and microgrid and also building automation. Okay, please.
Okay, thank you. Good afternoon, good morning, everyone. Thank you for joining this section today. My name is Wu Shankai from Tridonic, China. Today, I would like to share some thoughts about the future of lighting infrastructure, especially how lighting is becoming part of connected and intelligent DC energy systems. I will also introduce some real projects and technical solutions from Tridonic related to DC microgrids, smart lighting, and connected buildings. Okay, let's have a look. Before we go into technical topics, let me give a very short introduction to Tridonic. Tridonic is an Austrian lighting technology company founded in 1956. Today, we focus mainly on LED drivers, lighting controls, sensors, and connected lighting systems. One important point is that around 300 employees work in R&D, and a large part of our product portfolio comes from new product development. This is important because the lighting industry is changing very fast, from simple illumination to the connected infrastructure. Looking back at Tridonic's history, we can see several major technology changes. First, lighting moved from magnetic ballast to electronic ballast. Then came the digitalization. Tridonic was one of the early companies working on digital lighting control, which later became part of the DALI standard. After that came the transition to LED technology. And today, we are entering the next stage, connected lighting and smart infrastructure. Lighting is no longer only about illumination. It is also about sensors, connectivities, data, and energy management. Okay, there are some important trends we see in outdoor lighting today. First is solar powered lighting. Many cities want a lighting system that can operate more independently from the AC grid. Second is environment protection. There is increasing focus on reducing light pollution and protecting the environment. Third is adaptive lighting. Instead of brightness or night, lighting becomes demand-based. And finally, intelligent controls are becoming essential. Okay. Then also about the top trends about indoor. Indoor lighting is evolving in a similar direction. Efficiency is still very important, but now integration is becoming equally important. Lighting systems are increasingly connected with BMS, the building management system. Another important topic is dynamic lighting. Adjust the brightness and the color temperature according to time, activity, or daylight conditions. And finally, connectivity is becoming critical because lighting network, now it can also become data networks inside buildings. This is one of the most important slides in the introduction about section. Today, R&D in lighting is no longer only about LED efficiency. There are, I think, four major directions. First, adaptive and sensor-based lighting. Second, integrated system, combine lighting and building management. Third is about the human-centric and daylight-related lighting. And fourth, DC power system and the microgrids. The last point is essentially important because more buildings now integrate solar energy, battery system, and DC-based loads. Lighting can become a natural part of this DC ecosystem. Now we are moving on the main topic, DC microgrid. Why are people talking about DC system today? There are both pull factors and push factors. On the consumer side, electricity demand is increasing, energy costs are rising, and grid capacity is becoming limited. And on the government side, there's also pressure to improve the energy security and integrate renewable energy. Traditional AC grids were not designed for this kind of applications. That is why DC microgrids are becoming increasingly interesting. A DC microgrid can help improve efficiency, sustainability, and system reliability. First, many renewable energy sources and the batteries are naturally DC-based. Second, many modern electricity devices also work internally with DC power, including LED lighting, electronics, EV charging systems, and data equipment. In fact, LED lighting itself is naturally a DC load. Even in traditional AC buildings, LED drivers first convert AC power into DC power internally. This means every extra AC-DC conversion creates additional energy loss. By reducing these conversion steps, DC system can improve efficiency, simplify the integration with solar and battery systems, and potentially improve system lifetime, as well as the reliability. Okay, about our activities. At Tridonic, we are developing different DC lighting solutions, including 350 volts DC drivers, low voltage DC systems, and applications for industry, railway, horticulture, and outdoor lighting. The key point is that lighting technology must adapt to future DC energy systems, not only traditional AC infrastructure. Another important topic is open ecosystem capability. Tridonic is a board member of the Current OS Foundation, which supports open and standardized DC infrastructure. Helps improve system capability, scalability, and long-term investment security. This is a DC system experience center. Visitors will have the opportunity to explore the future of energy distribution in an interactive environment featuring a hybrid AC-DC microgrid and a variety of DC applications, including the EV charging, orbit setups, and the industrial applications. Additionally, the Experience Center will serve as an open lab for testing and prototype development, fostering innovation and cooperation with the DC community. This slide shows some actual DC lighting components used in the installations. We combine DC LED drivers with wireless controls and user interface. Today, power system and lighting controls are becoming more integrated. Of course, moving from AC to DC also brings technical challenges, such as voltage stability, protection, communication, and the system capability. Another important topic is how to smoothly integrate existing standards like DALI into DC system. That is why pilot projects and the testing platforms are very important for our real-world validation and future standardized. Okay, please let me bring you some application cases. Warehouses are ideal environments for DC microgrids because automated transport systems generate the required energy during the operation. This recovered energy can be stored locally and reused directly inside the DC network. Lighting becomes part of this energy ecosystem. And with sensor-based lighting control, additional energy savings can be achieved. Industrial production facilities are another strong application area. Factories increasingly use the robotics, automation, and battery buffering systems. DC system can help reduce conversion losses and manage peak loads more efficiently. Reliable DC lighting solutions are therefore important for industrial environment. Data center already operate largely with DC-based electronics internally. Lighting requirements are different here: high reliability, low maintenance, and intelligent control. For example, lighting can remain dimmed most of the time and only active when personnel enter the restricted areas. This improves both efficiency and the component lifetime. Outdoor solar lighting is becoming increasingly important. With local solar system and batteries, street lighting can operate more independently. Sensor-based dimming also helps reduce energy consumption and light pollution. This is especially attractive for smart city projects and remote locations. Lighting areas are interesting because they combine lighting, mobility, and energy generation, also with the solar solution. So lighting becomes part of a broader smart infrastructure platform. All these slides shows examples of our current DC driver portfolio. Here, the important message is that DC products are no longer only experimental concepts. Real pilot projects are already running today, and we expect more standard and wider adoption in the coming years of products and for new. Here's some slides about our outdoor application. Okay. Now let us look at the current outdoor lighting technologies. Today's outdoor system combines drivers, sensors, remote commission, and centralized management platform. Modern lighting systems also generate optional data to support asset management. This allows cities and the facility operators to monitor systems status in real time. For example, energy consumption, driver health, and maintenance planning. Lighting infrastructure is therefore becoming part of smart city data infrastructure. Also, this is the indoor part. Indoor lighting today focuses on 4 areas: digitalizations, linear lighting, spot lighting, and sustainability. But behind these applications, the key topic is connectivity and system integration. Room data is an important feature for connected lighting systems, and this is also supported by the latest DALI standard. The driver can provide information such as energy data, failure report, luminance information. All this data can be accessed through DALI or NFC, which helps simplify commission, maintenance, and lifecycle management. Another interesting feature is lifetime indicator. The system can monitor driver health and aging based on the real operation data. This supports the maintenance cycle, so maintenance can be planned before the real failure. In DC system, field AC-DC conversion stage can also reduce electrical stress on components, helping improve driver stability and lifetime. At the same time, connected lighting systems provide better control and real-time monitoring, especially in large smart building projects. This type of maintenance cycle is especially valuable in applications such as office, warehouse, production sites, and parking facilities. In large installations, lifetime indicator can reduce unexpected failures and can significantly lower maintenance costs. So let's have an overview about the system strategy for the moment and also for DC microgrids. I think lighting is no longer just an endpoint in the building. lighting systems are evolving from isolated luminaires into connected digital infrastructure. It is becoming an active part of the digital and imaging infrastructure. Today, we can combine lighting, sensors, wireless communication, building management, IoT platforms, and DC energy systems into one ecosystem. Today, we can combine all these things together, and this transformation is creating new opportunities for energy efficiency, sustainability, and intelligent buildings. That's all my sharing today. Thank you very much.
Thank you, Mr. Wu.
Thank you, Mr. Wu. Mr. Wu have bring us a great portfolio of the solutions of the lighting and also a lot of sharing cases and related to DC drivers, controls, and the consumption of energy. And also we see a diverse of a voltage architecture from 12, 24, 48, 110, and 350. And what we see in Luka's presentation just now, we have 600 volt DC and also 800 volt DC. We see a lot of differences, and we can see this kind of trend make this microgrids of DC quite flexible. And from this, we can see that for the technology, it's getting mature and mature, and building have more and more complex ecosystems, and also they need to coordinate across HVAC, HVDC, lighting, power distribution, and charging everything. So there are quite a lot of coordinations. And this brings us one question about how do these DC systems work together. And I see a question from Mark. Also, how these can reconcile this local success and through fragments to standard, global standards. That's very good. And we can go to the questions later on. Here, you can see this DC getting to be this trend. And we have these slides show you how you can join CurrentOS partner program. We have different kinds of program for different organizations. You can look into these slides to select according to your business purpose, which level, which grade you would like to join us to create this DC world together. Peter, you are going to bring us for this upcoming international conference. Please, Peter.
Okay. Thank you, Dory. So I think this today's presentation is very impressive because building the majority energy is consumed by HVAC and lighting. So in the future, if more DC applied into our buildings, it will improve the energy efficiency a lot and reduce the carbon emission. But the standard, the offer, the product also need to iterate. That's why CurrentOS want to collaborate with you to define the spec and then become a standard in IEC, in UL, in worldwide market. Let's work together to boost this market. And we are working on the industry side. We can see, well, academic side is working very hard to promote this technology and create standards for us. So this year, maybe next week, we will have the IEEE ICDCM International DC conference meeting in Xi'an, China. It's first time organized this meeting conference in China because I suppose for direct current ecosystem, we have very strong ecosystem and industry partners here. So we invite you to join with us with CurrentOS or sign up or register to join the IEEE ICDCM in Xi'an next week. We can have more in-person exchange, and I hope to hear more insights from you and we can work together on the CurrentOS. So how to join this IEEE ICDCM? You can sign up on the website, search the 2026 ICDCM, and you will get the link. So we invite many distinguished keynote speakers from worldwide market, from Europe, from US, from China, from universities, distinguished professors, and also from state grid, from industry leaders like ABB, like Siemens, like Schneider Electric. So we will discuss together, have several panel sessions to discuss different topics. Some focus on DC protection, some focus on the DC application. So we hope to meet you in person next week in Xi'an. So by the way, CurrentOS, we are work closely with IEEE SCDCM. We will organize the DC industry networking workshop. We have more interaction with your business companies. If you are a CurrentOS member, you will get opportunities to connect with us, and also you can sign up for the IEEE SCDCM. So looking forward to meeting you in person next week in Xi'an. Okay, let's move on to the Q&A sessions.
Yeah. Okay, as I see in the chat, there is one question from Mark. So China has forged ahead with proprietary DC building deployment, but how do we reconcile this local success with fragmentation of global standards like CurrentOS, Emerging Alliance, and IEC?
So Mark, this is question for me or for Mr. Li or for Mr. Wu? Mark, are you on?
To anyone, actually, yes.
Yeah.
You can answer it. That would be fantastic. Thank you.
Yeah, so CurrentOS actually is working closely with our industry leaders and also IEC LVDC synchronized team. So we need to make sure our spec is qualified enough, and we need to pass the test and got common agreed about our spec, and then we are promoted as our IEC standard, and also got recognized by you as well. So we in the future DC power distribution, we hope to create a unified standard for worldwide market. CurrentOS is a platform to leading these industry leaders, universities, certification agent, test lab to work together and to create a solid technical spec, and then help to promote it as a standard. And this standard can used both for IEC and UL. May I answer your question?
Yes, please. Thank you. Thanks. Yeah. Thanks, Peter.
Thank you. Any other questions? So I have a question for Tridonic and also for Hisense. Maybe Hisense can answer first. I would like to know what the unique value does CurrentOS ecosystem bring to your product and your company? Yeah, Mr. Li, you can go first.
Okay, so actually CurrentOS provides a plug-and-play interoperability and enabling Hisense to develop the products that can integrate it into the DC microgrid and also connect with other key components such as the coupling box and photovoltaic and other grids. This reduces the dependency on AC/DC conversion losses and lower the system complexity, of course, and accelerated the time to market for energy-efficient products aligned with global net zero goals.
Okay, thank you. How about you, Mr. Wu?
I think that is a very important point is the ecosystem compatibility. Tridonic, we as a board member of the CurrentOS Foundation, we appreciate that the goal of CurrentOS is to support open and standardized DC infrastructure across different industries. This is very important because DC microgrids cannot grow successfully with the systems. An open ecosystem helps improve interoperable scalability and long-term investment security. So it's too important. It's very important. Yeah.
Okay. Yeah. Yeah, I saw the new question coming from our chart. So
what is exactly this high efficiency LED driver means in case of lighting using DC supply? Is it a specific made in high capacity LED bubble type? Okay, I think this is quite a question to Tridonic. Yeah.
I think yeah, we are in the same I think we are from the same industry, lighting industry, but for a bubble type, I think that will be some challenge because bubble as a light source, it's highly integrated with the very small drivers, chips, and the thermal system, everything together. So from our side, because Tridonic are making LED drivers, we can using the power supply technologies to adapt for DC as well as for other AC or other DC. But for bubble, I think firstly DC can simplify the topologic inside and can help to make the bubble smaller. But it also requires different standard because bubble is already end products. So with our products, the driver, that can be a different topic.
Okay, Marco. Yeah. Thank you for your question. And a follow-up question for Tridonic. Lighting is naturally DC. How do you see DC architecture simplified or transforming lighting system in the smart buildings?
In fact, I already mentioned in my presentation that LED lighting is naturally a DC load. So even in the traditional AC buildings, LED driver, firstly, it needs to convert AC into DC internally. So with the DC microgrid, we can simplify the power architecture by reducing in unnecessary conversion stage, also suitable for bubble application. This can improve overall efficiency, reduce the component stress, and simplify energy integration, also with the batteries and the solar systems. So it's very interesting.
Okay. Thank you, Mr. Wu. And I also have the similar question for Mr. Li from Hisense. What changes are needed in appliance design to fully leverage a DC-powered building?
Yes. Actually, to fully leverage DC buildings, we must do several things. The first one is the integrate native DC input. That's the eliminating internal rectifiers. Okay, and the second one is the embed smart controls for real-time load balancing and grid responsiveness. Okay, and the third one is adopt modular designs to support by directional power flow. And the fourth one is to optimize voltage compatibility. Okay, to reduce the component count and the cost. Okay.
Okay, good. And follow-up question: how important is the standardization to scaling up DC adoption across industries?
Actually, it's really critical. Okay, without standards like current OS, interoperability barriers block the market development, of course, and also non-standard design cost always high, and stagnation of economy value development. Okay, under the standardization, risks investment, simplify compliance, and enable cross-industry ecosystem like HVAC or EV or storage, some other things. Okay.
Okay. I see the new question from Mark. Yeah, Dory.
Okay. Okay, let's finish this last question and then we close. So question from Mark: does this building level DC infrastructure provide measurable advantage in demand response latency compared to the traditional AC coupled battery and EV setup? I think both of you can answer this. Maybe Hisense, please. Look.
Yeah, Mr. Li. I think this question is more for Hisense. Yeah.
Sorry, I think my signal is a little bad. Can you repeat again?
Okay. So the building level DC infrastructure provides measurable advantage in demand response latency compared to traditional AC coupled battery and the EV setups. So
the EV setups.
So means what the advantage for the response latency, this kind of delay of responding compared
Okay, so
AC to the DC infrastructure, what is the advantage in the terms of response latency?
okay, so for our products, I think our products is suitable for both DC power supply and AC power supply. Okay, and actually our equipment can communicate by the communication wire with other third party or other equipment to give us the signal just to operate with the DC power supply or AC power supply, and also all the functions are the same, totally the same inside our products. So I think for only focus on the air conditioner, the power supply is not the most important part, or the efficiency is almost the same for DC or AC power supply. But for the whole system, DC to DC or DC to DC, of course, it must reduce the power consumption by the other equipment and all systems, just like this. And also, I don't know. We have a lot of cases using in the market, but actually the cases are just using for about several months or less than 1 year. So probably we can't get the data from them. But actually, I have found other data from data centers. If we use the DC to DC, probably we can reduce about 15% of the power consumption.
Okay.
Okay.
Thanks for that, Luka.
Okay.
Yes, power consumption and peak power also. Peak capacity is softened. Sorry, I'm adding what we saw in your presentation earlier.
Yes, droop control is the most important, of course, for especially for the air conditioner. Yeah.
Yeah. Okay, we are a bit run out of the time. So
Yeah, I have a follow-up question to Schneider.
Okay.
Yeah. So you can see there, while the efficiency gains of eliminating AC/DC conversions are very clear, what does the actual CapEx premium look like for the AC native switchgear and protection devices today?
You mean the CapEx for the protection device?
Yeah, for the DC native switchgear, the actual CapEx premium.
Yeah, so for Schneider, we are developing the SSCB, and in China, we already launched our product for the DC buildings. We can see the cost compared to the previous mechanic breaker is higher, but from long-term perspective, from the energy saving perspective, if you have PV and energy storage, so the payback is around 3 years.
Okay, 3 years. Thanks.
okay, there is another question from Rama. How much of a common household and commercial office HVAC equipment are DC right now? This question is for Luka. How much? Yeah, actually, we get this question, but I think we need to make a list how much this kind of equipment is available for DC. Luka, from your perspective, how much?
How much the equipment? That means for our air conditioner?
Common household and commercial office HVAC equipment.
It's hard to say. Of course, DC needs more money, as I just answered the other questions. We need to set up a microgrid inside the house, of course.
Can I brief it?
Okay.
Yeah, I'm actually dealing with the buildings hybrid and hybrid AC/DC architectures. Clients are asking on whether there are any equipments readily available for the household and also for the commercial offices, HVAC equipment which can be converted directly to DC. Because I'm dealing with the architectures and they need the confirmation from any of the manufacturer whether there are any equipments available to use directly in DC.
Yeah. Maybe I can pick up on this. So we have a software we partner with, which is called DC IDE. I will mention it in the chat, which is providing all the DC compatible available product on the market. So this software will help you build your microgrid and will help you define. Sorry, I will share my screen. DC IDE will help you find the products available on the market today. There are many already.
Okay, thank you.
I will share the link now.
Okay, thanks. So we are running out of the time. So thanks a lot for all the sharings from Hisense and from Tridonic, from Luke and Mr. Wu, and both demonstrated as technical in-depth and innovation in DC system, and also a lot of applications. And also, it's very important to thank you all for joining us today, for your questions, for your attention, and for the commitment we are building together for the DC transformation. Okay, so this webinar will be recorded. It's recorded. The link will be available soon. And if you have follow-up questions, and so you can leave your questions, and we will try to answer as much as we can. Okay, so let's call this session a close. Thank you very much. Thank you all.
Thank you for questions.
Okay, thank you. Thank you a lot. Bye. Have a nice day.
Thank you very much.
Bye.
Bye.